And then we have skipped some questions in the chat. One was just too late from Christian Felici to Arturo. Do you want to give the question by your own?
Well, we already have answered that question. We had it in the chat.
Okay. And there was a question by Chukwaya Anorua on how best to use PRN of GNSS. Do you want to explain your question a bit more, or? It seems that he's not with us anymore. So it means PRN is just a label that you have at the observation when you get it from the receiver. That's why we have it in the Rhinex, and just for convenience, we used also the PRNs in the SP3 file, in the precise orbit files. But this is an artificial number that has nothing to do with the satellite hardware. So we have, for instance, seen in the presentation from Stefan that the PRN number that was used can be generated by different physical space vehicles. And all what is related to the hardware, the satellite, is related really to the space vehicle and not to the PRN. So from this, it is wise to switch to PRNs when to SVNs if you want really to address satellite hardware. Is this answered? And now we've got one from Lars to Johannes. Lars, do you want to present your question by your own? Lars?
Can you hear me?
Yes, we can.
Oh, sorry for the delay. Yes, is there advantage of VMF3 mapping function very significant compared to using VMF1, in your opinion?
That's thanks for the question. Yeah, that's well, in terms of the mapping function part, I would say no. I do not see a clear advantage of the VMF3, but the advantage of VMF3 is that it has a 1 × 1 degree resolution, and VMF1 has this 2.5 × 2 degree resolution, and actually it's an advantage for the zenith hydrostatic delays. So I would think, or I'm pretty sure that the zenith hydrostatic delays which are provided with the VMF3 are a bit better than the hydrostatic zenith delays with VMF1. But in terms of the mapping function itself, I would say rather no. Mm-hmm.
Okay, thanks a lot.
Okay, then was a question from Bruno Kuyamurevire. Sorry that I am not able to pronounce it correctly. On PPP code solutions. Are you still in the meeting? Can you present your question by your own, that I really understand what is the point?
Yes, thank you. Good morning, good afternoon. I am Bruno from Uganda, and recently I did a static observation then processed using PPP, but unfortunately, when I looked at the type of solution, it was a code. And when I looked at other reports that I had processed before, they had a phase fixed. So I really wanted to know what is a code solution and what are the causes in PPP in particular. Thank you.
So code, you really mean the pseudo range observation type instead of the phase observation type. So the difference is the noise level. In code, you have about 100 times higher noise level than in phase measurement. And I would expect that your code measurement is much less accurate than the phase measurement, even in particular after ambiguity resolution. So for precise applications, it's recommended to go for phase measurements. Then we have Andrea Gatti with a question.
Yes. Hello, can you hear me?
Yes, we do.
Yes, thank you very much for the very interesting presentation of today. And I wanted to ask, well, it has been shown that the mapping, a wrong mapping function at lower elevation can make a lot of difference in the final results of the estimation of the height and the tropospheric quantities. So there is always a drawback on the weighting function that I would like to use to estimate the tropospheric quantity. If I use a uniform weighting strategy for my observations, I will get that a wrong mapping function will generate an error in the height and the tropospheric estimation. If I use a weighting strategy that weights too much the zenithal observation, I will have the opposite effect. And my estimation will be poor. So is there, from you expert, weighting strategy that I can use that is suggested from you to be applied for retrieving tropospheric delays?
Thank you for the question. It probably goes to me, but actually I have to forward the question to Rolf, because
okay.
I'm not a GNSS person. I'm rather a real bad person, but I know that Rolf has the answer, or one answer.
Oh, I don't have the answer. So if
There is not, probably.
if you ask all the different analysis centers that we have today in this meeting, then I guess you will get nearly as many answers as we have analysis centers. So there it's a bit taste in between exact with the trade-off that you have described. And I would not say decide which of the weighting schemes that is applied is really the optimal and really best. Tom, do you have another opinion?
No, I was just going to comment that if you actually look at the phase residuals as a function of elevation angle, even on short baselines where the atmosphere is negligible, you see that it increases something like 1 sine of elevation angle just from the gain on the antennas. So the minimum in terms of a least squares consistency is at least to put in something like a 1 sine of elevation angle. That then tends to diminish the impact or the quote improvement you get by going to lower elevation angles, because the data noise is treated as being larger down there. In terms of systematics in the mapping functions, it's probably a similar sort of behavior, I suspect. So,
yeah.
So I'd say anything.
So you should go square.
Well, in standard deviation, 1 over elevation, variance 1 over elevation squared.
Okay,
But there's
thank you
also
very much.
There's a
Yeah,
constant
there are
phase.
analysis centers that apply a weighting only below a certain elevation, or also with a bit more clever function than just a sign, but in fact, it's something that direction.
Okay, thank you very much.
Okay, then Claudia, is raising her hand.
Yes, thanks, Rolf. I have a related question also for Johannes on the gradients. So you recommended to estimate them every 3 hours. And I was wondering if the IGS analysis centers are really doing that, or if they use 24-hour resolution. That's what I thought. So, and also for the IVS, I think they are using 24 hours. So where would the 3 hours come from?
Yeah, that's also a good remark, and probably too much into VLBI here. So, so obviously it's 12 or 24 hours. Yeah.
The MIT, at MIT we do a linear gradient over the day. So yeah, the more gradient type points you put in, it increases the noise in the solution, and so it's a balance of the signal to noise ratio. I would say in general, in terms of analysis, I think one of the things nearly all the ACs are somewhat deficient at is we know there are some days when the weather is absolutely beautiful and there's probably very little gradient in the atmosphere. And then there's other days where you have massive thunderstorms or something around where there can be massive gradients. And I don't think any of us are particularly good at accounting for that difference in the weather in the way that we actually do the a priori constraints on things like gradients or the number of gradient elements we estimate for the day. There's also, just as an aside, there's also some really great sites where all of the position estimates are very skewed in a particular direction. Anyone who wants to look at atmospheric modeling, that's still one of the outstanding problems, is we clearly see this skewness that the site tends to always have motion to the east and maybe down, and then it doesn't have the corresponding errors into the west. And that's presumably a topographic atmospheric interaction effect.
Okay, thanks.
Then is in the chat the question from Eteshu, Shetu.
Yeah, I'm afraid that Tom and Rolf, you again have to jump in here.
Oh, Tom, double difference GNSS analysis are performed on a sufficiently large area. I don't really understand the question. So I think I have shown in my presentation that it doesn't make a difference whether you do a double difference or any other GNSS network solution, you get equivalent results.
Yeah, the MIT analysis is global double differences. The complication when you do global, and we have a fair amount of code devoted to it, calculating the number of non-redundant double differences that are possible. Because it's normally you have some number of stations, some number of satellites, you know what the maximum could be, but there's an observability condition. And on local networks, that's pretty easy to calculate. But when you go global, you've got measurements across the pole that you can get and things like that. So just getting the right combinations can be tricky. As Rolf said also, it's very important that when you do it, you actually take into account the correlations that you introduce. That you have really fooling yourself on the statistics.
And you're cheating somehow in some direction.
And in theory, if you do the correlations and you take all possible combinations, the specific order that you do things doesn't make a difference. And certainly we've verified that in
at least in small networks, you can easily show it. For larger networks, it becomes difficult to catch all the observations that you have in a zero difference solution.
Yes, that's right.
You have an advanced bookkeeping somewhere.
Yeah. We think we do that, but we're never certain.
Yeah. Okay. Was this the question, Eshetu?
Yes, exactly. Thank you.
Okay. Welcome.
Hand up, Rolf. For Zhao Zhang. We have a hand up from Zhao Zhang.
Yeah, we have a hand up.
Yes. Hello, this is Shao, and for all the presenters about their interesting presentation. And I just got two questions for the presentation about the clock. The first is for Michael, and I noticed that thanks for the explanation about the modeling of the clock. And I just wondering about you mentioned the noise modeling, that you use the white noise and also the random walk noise. So I wonder, is this based on some basic hypothesis, or is it just related to specific physical and background? So I am not quite sure about that.
So we use white noise. I mean, noise can be broken up into a spectrum of different types, right? So there's white noise. You've got random walk, random run. Now, in between, you do have layers of flicker noise, and clocks do have that. They have that whole spectrum. But when you're looking at a model that has, you're building the deterministic component of phase, frequency, and drift. The derivatives only look at the even powers of the power law when it decomposes. So you miss the flicker and all of its subderivatives. So this is the reason we tend to look at the random walk and random run. Now, why do we know that those are there? Because there is white noise on the frequency. I mean, clocks are usually trying to maintain a frequency, and there is white noise there. And we know that that's going to integrate up into the phase just by nature of how that model is devised. I don't know if that answers your question, though. Does that answer the question?
Yes, because I know this models before, but I just don't know why they are related to this modeling of the noise, and is there any characteristics of the specific noise modeling in terms to the different parts of the noise you have showed in the presentation? Yeah, that's a answer for my question. Thanks.
Sure.
Yeah. And the second one would be from the presentation boards, and thanks for the interesting demonstration of the PPP errors using the different interpolation intervals. So as you have presented, I noticed that the block 2R clocks has lower performance than the block 2A, but according to my understanding, benefiting from the modern technology, we should have a better performance for the new satellites. And I think you have mentioned the clock is not only related to the real clock, but also to how we measure it. So may you explain it more about this phenomena, or this what I didn't expect? Thanks.
Yeah, so I try to answer. Of course, I cannot really answer because I have not enough knowledge about the clocks on board of the GPS satellites. Yep. That's of course not all information is available, but of course the important thing is that you do not measure the clock as the hardware on board, but you measure the whole system. So it's not only the rubidium clock, but it's the whole equipment, and in that case, it's the timekeeping system. As I read somewhere, there's a phase meter which introduces some noise, while the clock itself would be significantly more stable, and one can see that on the long-term behavior. That the rubidium clocks in the Block 2R satellites are much better. So it's simply something on board which degrades the clock when generating the signal.
I think you did mention.
Maybe Mike knows maybe more about it.
You did mention that the TKSs on board the Block 2Rs are responsible for a good amount of the short-term noise we see there. But one of the things that I didn't really draw this point, but when I was showing those longer histograms, GPS was not performing as well as Galileo when you look at those histograms for short term, because the Block 2Rs were included in that mix, but they equalized in longer term because the short term noise isn't a problem when you start to average out at longer intervals. So it really showed that the 2Rs are actually fine when you start to get out of the 1 minute to maybe 1 hour range.
Okay. Thanks for the information and explanation for that. Thanks.
Sure.
So, okay, there came another question in from Yisheng Liu.
Yes, thank you very much for all the very nice presentation. So I mainly have a question goes to this OSB products. So for example, I only analyze this OSB products from Connect Center, and then as it is expected to be quite stable, like during the whole day. So then, although I did observe some quite big jumps, like for example, for Galileo E5b or E6, like I observed like jumps around like 20 millimeter in between. And I wonder what is the reason for that and how should I cope with it, like when I have such problems.
Difficult to answer the question because you address here a specific product. So we actually should ask the CNES people. And in fact, they should also know more details. So exactly which linear combination is affected, which quantity you exactly mean?
Which like
Felix is in the meeting, possibly also somebody else from the case group.
Yeah, I'm attending the meeting. Yeah, and unfortunately, I guess you're talking about real-time USB products.
Oh yes, right. That is from the PPP wizard, like the real-time products. Yeah. True.
So I'm afraid I cannot help this because I'm not involved in the real-time activities. The only thing, my only comment will be that it's always, I would say, difficult to compare biases. It's always a kind of relative thing. So making differences, comparing differences of biases means something, but not absolute values of biases. So I don't know how you are doing your comparison. But anyway, in any case, talking about the real-time biases, I'm not able to help you. I'm sorry.
Yeah. Okay. Okay. And I just simply want to ask what, like, if you have a general solution, like if I ever came across such problem, like, because I'm not, I just like do the analysis for the like products that I get. I haven't made any comparisons yet. Like I just simply try to see how it goes, and then I've had such like issues, and I don't know how to deal with it. Or maybe I should just change a set of products.
Well, yeah, I'm sorry, but I cannot help you on this. Please don't hesitate to contact the team who's involved in this, in producing these products. I'm sorry.
Yeah. Okay. 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 Thank you very much.
That means this is, or there was another question related, really real-time convergence time. So I hope I don't speak about secrets here, but we have had discussions on potential topics for future stops, and there one keyword was real-time, and I would suggest to postpone also this question to a future issue of this series. Myra or Alice, you can kill me if I said something wrong here.
No, absolutely. We're welcome always to have ideas for different workshops, and that actually suggestion has come before as well. So we'll take that into consideration.
Exactly. There was another suggestion on a workshop on the product generation, on the analysis center level, how to generate orbits, clock Earth rotation parameters, and so on. And yeah, maybe we put it on the list of potential topics that we have and take a note on this. And then there's
excellent suggestions.
Yeah. And then there was another question that we have just skipped, because it was a bit early. It was, I haven't heard that we have spoken about quaternions. It's something what is related, of course, to the orientation of the satellite, and somehow each analysis center is modeling the orientation of the satellite, at least in minimum in a nominal attitude control, that the solar panels are oriented towards the sun, that you get the solar radiation pressure model. But until now, we haven't distributed or exchanged this value. For the recent repro, this repro 3F4, it was stored for each analysis center for the first time and also put to the database at CDS. And the other question in this, the other point there was something on satellite dynamics. This I would put in the same corner as the previous question as well, that we would need somehow a special event to also about orbit modeling. So the sampling of 15 minutes from the SP3 files is done by purpose, that you can just interpolate without using any force model between the satellite positions, and get in this way continuous representation of the satellite orbit in the Earth fixed frame. And because we have now with Galileo 2 satellites in an elliptic orbit, there we need a higher sampling of 5 minutes, and this is also the reason why some products are switched meanwhile to 5 minutes. Is this accepted as a preliminary answer? Okay, then my sheet is now empty. Did I forget something? Oh, there is a new question in the chat. Hilda Silva, do you want to present it directly?
Hello, everyone. Yeah, I would like to know a bit more how ambiguity resolution can be performed in the user side. I know this depends on the corrections that we are applying, but could you please elaborate a little bit more?
Your question contains two parts. So the second part is whether this could be applied for data from low-cost receivers, and this really strongly depends on the quality of the data. So this is the crucial thing. And the second thing is concerning the ambiguity resolution approaches. So we deal with longer time spans, and there this is not really a very demanding task. So we do not use, for example, lambda strategies. Also for the LEO applications, not. But this would be a subject for future scientific discussions, of course.
Yeah.
Okay, so for a low-cost receiver, it wouldn't be possible, or it would be very difficult.
Again, as I said,
the performance of the low-cost receiver
depends on
it's really
the performance.
A question of the data quality.
Yeah.
So the systematic errors, in particular in terms of the pseudo-range measurements, the noise characteristics, also in particular for the pseudo-range measurements, and finally also the quality of the phase measurements.
Okay. I don't see other questions on this, I think we are at the end of the today's stop of the tour of the IGS. I want to thank the speakers for their contributions. I hope that this gives the inspiration for the user community of IGS products, and I hope that you also see that there is a lot of work to generate these IGS products that you just download. And what I expect in minimum is to add the reference to when you use IGS products or data from the IGS to acknowledge the work that is done by this significant group of people. So, and with this, I want to hand over back to Alison and Mayra, who have organized the technical side of this meeting. Thank you for your attention.
Yes, and thank you all. Special thanks to Myra and Ashley at the Central Bureau, who have been the producers of this event and making sure everything ran smoothly. So I'm sure for many of you, it's a late night or an early morning. And thank you all. And thank you, Rolf, for this idea and for leading the organization of this event.
Yeah. Thank you and goodbye. Have a nice day. Nice night.
Bye all.